Bro, I can't shoot him. I don't have range. I do not have range. You have the sniper. Snipe him. He's shooting at me. Down now. Thanks.
Right. Hey, class.
Pick me up. Pick me up.
Seve.
Pick me up.
Seve. Seve.
Dude, I gotta go. I'm sorry.
Hey, I'm sorry I'm a little bit late. I had a couple of things to do. I appreciate you sticking around, though.
Yeah, everyone, it was weird. Everyone just kind of left, and I knew you'd be here eventually, so,
I appreciate that. Even though I'm 45 minutes late, I really appreciate you sticking around.
Yeah.
You ready to get started?
Yeah, I'm as ready as ever, Professor.
All right, let's get going. Can you still hear me?
Yeah. It looks good. What do you?
Oh, just ignore those tabs. Let's just get right into it. Is everything working? Can you hear me? Is the connection good?
Yeah, it's crystal.
All right. Today we're gonna be talking about dark matter. But first things first, I just want to let you guys all know. Oh wait, it's just you. But I want to let you know, even though this online class is a big adjustment, I want you to hang in there because I know you can do this.
I'm hanging.
Before the Hubble telescope, we knew two things about the universe. One, it would have enough energy when it was created that it would expand to a certain point and then recollapse because of gravity. Or the second one is that when the universe was created, that gravity would it'd keep expanding forever, but gravity would slow it down to a point. But that all changed in 1998. The telescope made an observation in deep outer space. It was observing a supernova, and when it was looking at the supernova, it observed something that was completely shocking to the whole astronomer community, that the supernova was actually expanding quicker than it was a long time ago. This leads me to my next point. Astronomers had to come up with a conclusion of why the supernova was expanding at a quicker rate when it should have been slowing down over time. We pointed to dark matter. Dark matter was discovered by astronomer Vera Rubin. She was studying galaxies. She was observing them. And when she was observing them, she came to the conclusion that the farther out stars are in gas from the center of the galaxy, they should be moving slower. But what she noticed was these gases and dust on the outside of are moving even faster. Gases and planets that are on the inside of the galaxy core. We came to the conclusion that this is actually dark matter that is containing the whole galaxy. Why is it called dark matter? Is because it does not reflect any visible light, so we don't really even know what it is. Dark matter can move through all types of matter. So it could be moving right now through us, and we don't even know it, we can't feel it, reflect any light, but it also has a very strong gravitational pull. This gravitational pull encourages the growth of structures, which is why we see a lot of galaxy clusters together, because this dark matter is pulling galaxies together. And we know dark matter is there because there's not enough matter or gas and dust on the outside of the galaxy to maintain itself. Another fun fact for you is the matter only takes up about 4% of actual universe. 26% is dark matter. So what could dark matter be? There are many possible candidates for dark matter, but axions are a very popular candidate. Axions, a hypothetical subatomic particle of low mass and energy that is thought to exist because it has very strong gravity in formula in mathematics. We have no idea what they look like, but these axions can move through matter without being disrupted, which is why we think it is dark matter. That is all I have to present. Do you have any questions, Seve?
No, I'm really glad you gave me the chance to ask a question right now, but I'm gonna actually use that time. I'm gonna teach you something. All right, my main home slice, Bill Nye the Science Guy and Neil deGrasse Tyson, they've taught me quite a fair bit of astronomy. You're definitely a little bit underneath them as far as like credibility. God, this Google Meet stuff is so frustrating. I don't understand how you guys do it.
A few moments later.
Dark energy, it makes up the majority of space, like I just said. Given the percents that you gave for visible matter and translucent dark matter, it makes up about 2/3 that you just kind of left up in the air. It's kind of really the only somewhat credible explanation for why the universe keeps expanding at an accelerating rate. Just the fact that they make up the majority of our universe, it suggests, it kind of just dabbles in the idea that it's not going to stop. It's just going to keep expanding.
Hey, Seve, quick question.
Yeah,
When
that's
did you have
wonderful.
time to make this?
So eventually, celestial objects will, as they're speeding up, they're expanding at an accelerating rate. They'll just keep on moving faster and faster and faster and faster. And theoretically, at some point, and we're talking trillions of years in the future, uh, they're going to be moving at the speed of light and even past that. So, say in trillions and trillions of years from now, which a lot of theories predict that Earth will not continue to exist. Say it did, the night sky would be completely black.
Interesting. Seve, you have blown my mind.